you've been programming in C#, there's no doubt that you've heard about LINQ, but a lot of people misunderstand LINQ and what it does. LINQ can greatly simplify a lot of really complex things that we would otherwise encounter when going over collections. And like they say, with great power comes great responsibility, so I think that it's really important you understand how LINQ works, and in this video I'm going to explain what it does and how you can write your own LINQ methods as well. Before we head over to the code, just a quick reminder to check that pinned comment for a link to my free weekly newsletter and courses that I'm working on. Alright, let's jump over to Visual Studio. So LINQ stands for Language Integrated Query, and we're going to be looking at LINQ operating on IEnumerables. Now there's three different things that I want to call out that LINQ can help us with, and that's mapping things, filtering them, and reducing them from a collection down to one thing. And we're going to go through examples of all of these before we see how we can write our own LINQ methods. And along the way, I'm going to demonstrate something that's a little bit tricky with LINQ, so you're going to want to stay tuned to see how that works. The first example that I want to walk through is mapping things, and that means that we're going to be transforming different elements that are inside of a collection. In this example, I'm just using a list of integers, and it's called numbers. We can see that on line 11 here. So this is a new list that just has 5 integers in it from 1 to 5. And it doesn't have to be a list. It could be an array or any collection in C#, because collections implement IEnumerable. So that's the minimum requirement that we need here. As long as whatever you're dealing with implements IEnumerable, you can use LINQ on it. So to see what this would look like without LINQ, I have an example from 13 to 17 here that shows creating a new list. And because we're mapping things, what I want to show you is going from a list of integers to a list of strings. And what that would require us to do is have this new list that I declare on line 13 called numbers as strings. And what we're going to do is go with this for each loop where we take each number from numbers, and then we call toString on it right here on line 16. And for each one of those, we're going to add it into the list of strings that we've just created. So at the end of running this loop, what we'd have inside of numbers as strings is 1 to 5, but as strings instead. So this is how much code you would need to go write to be able to do this. Or what you could do is use the select LINQ method, which I have here shown from line 20 to 22. And what I've done as well is split out this code across multiple lines, because to me this is more readable instead of having one really long line of code, which you can have happen pretty easily when you're chaining some LINQ things together. I like stacking it vertically. And this is a pro tip, because when you're working in code bases that have really wide lines of code, especially if you have to use a scroll bar to go left to right, it can make things really difficult to read. And if you don't believe me, spend some more time writing code and try seeing the difference when you have to scan really long lines left to right in many lines of code. So what we have on line 20 is we take numbers and then we call the select method, and this is a LINQ method that we have. If you haven't seen this arrow syntax, or it seems a little bit confusing, what we're doing is saying that this is going to be a variable called number, and this is just like when we have this for each loop where we say int number. It's the same concept. We're just giving a name to the element that we're using on each iteration of essentially a for each loop. And then, like you can see here, I have number to string, which is just like this part as well. But the difference is that when I'm calling this select method, I'm not putting it into a list like we have on line 16 here. I'm not doing this part. We don't see any of that here. But what I do to put it into a list is at the end, after we call select, I say toList. And a little bit later in this video, I'm going to explain why we have the .select and still need to do a .toList as well. But to briefly mention, doing .select here just gives us another IEnumerable, and doing toList is what's going to put it into a list. Okay, so now that we've seen mapping things with LINQ, which is essentially going from one value to another, so we're just converting each element in the collection to something else, filtering is instead going to be removing things. So we just want to focus on keeping a certain set or excluding things that we're not interested in. So to see what this could look like without LINQ, I have an example from line 26 to 33 here. And what we're going to be doing is looking at taking that numbers list that we just had, and we're going to get the even numbers only. So what you can see on line 29 inside of this for each loop, so we still use a for each loop just like before, we're doing number modulo 2 and checking to see when the remainder is equal to 0. This is a really simple way that we have to check for even numbers. So every time we have this condition met, we're going to add the number that we're checking into this even numbers list. So much like before, we're still going from one list that we're iterating over to another list that we're going to add new things into. But as you might imagine, because this is not going to meet every single number that we're iterating over, it's only going to take the even ones, which means the final collection that we have is going to be potentially fewer numbers. And because we know it's numbers 1 through 5, we know it's going to exclude things like 1, 3, and 5. But again, this much code is needed to do it without LINQ. Now, if we see on line 36 through 38, we have the same idea that we saw before with LINQ, but instead of select, we're using where. So where is what we use to be able to filter things. And we have the same arrow syntax. So we're just calling the element for each iteration number. And then inside here, we're saying when the number modulo 2 is equal to 0. So this part that I have highlighted right here on 37 is equivalent to what we would have to do with this if statement. And again, we have to have a .to list there because just doing this where is going to do the filtering, but it's only going to have it in an IEnumerable. We still need to put it into a collection. And again, if you wait a little bit longer, I'll explain why this is so important. But the final thing that I want to look at before we explain that little detail is reducing things. So we've seen mapping, we've seen filtering, but reducing is going to take that collection and reduce it down to a single thing. So if we wanted to get the sum over this collection of numbers that we have, and you could do things like average or min or max, but sum is just the example that I picked in this case. Again, we're going to have a for each loop, but what's interesting, just to kind of call it out early, is that instead of having another list that we're putting things into, I only have one thing. It's just the sum. It's not the list of even numbers, and it's not the list of converted numbers to strings. It's just one element. And like you can see, I've had this for each loop, so again, very much like all the other examples. And then each iteration of the loop, I'm just adding the number to the sum. Pretty straightforward. And if we look how we would do that with LINQ, on line 48, it's just numbers, and then we have a sum LINQ method. So extremely simple. There isn't a min, there is an average as well. So you could do min here, you could do average. You have access to all that stuff, which is great. So you don't have to go write your own methods like this. So it's really handy. But what you should notice is that just like I mentioned how we don't have a list here on line 41, I don't have to call .to list after line 48 when we do the sum. And that's because the sum, the result of trying to calculate this, is just a single number. And that's what we mean when we say reduce. We're going from a collection down to one thing. Okay, so what's the big deal with doing the .to list thing? Well, let's go into that right now. So LINQ methods are lazy, which sounds kind of funny. So what does it mean to say that LINQ methods are lazy? So when you're just doing .select or .where and we don't call the .to list, nothing actually happens, which sounds really funny, right? Like, what do you mean nothing happens? Well, what I mean is that we're not technically stepping over all of that stuff. And I wrote this little bit of code here because I want to show you that and prove it to you. So this example is going to use a select here. And you'll notice I don't have a .to list after line 62, right? There's just a semicolon. There's no .to list like the other examples we saw. But what's unique about this one is that every time we're about to go return something as we're selecting it, so this is just converting the number to string, I'm going to print this to the console. And what I want to show you is that this code is going to run, we'll step over it, and we'll see this line that says after LINQ line for lazy numbers as strings, but we're not going to see this get printed to the console. And we're not going to see this stuff get printed to the console until after this line gets written. And that's because on line 66, I'm going to be forcing the enumeration by calling toArray, which is just like saying .to list, but instead of a list, I'm getting an array. So toArray, to list, doing a for each loop over it, that's going to force this part to execute. And I want to prove it to you, so let's go run this. Okay, and just like I said, we see after the LINQ line for lazy numbers as strings right at the top here, followed by every iteration that says transforming. So that's this line, 63, running before all the stuff you see above it. And then we see after forcing enumeration, lazy numbers as string, which is printed right here. And just to reiterate why this happens is that until we force enumeration, so toArray, to list, for each, until we do something like that, this select method, it's the same thing with where, they don't run any code. it's really just a function pointer. So we're setting this up, but nothing's evaluating it yet. What's different about sum or average or the other ones that do the reduction is that those will automatically go execute. And that's because they only give you one thing back. Those are not lazy, but doing the ones that I just mentioned will be lazy until you go materialize them or iterate over them. Now, this means that there's yet another catch with using LINQ, and this one is super important because I see people making mistakes with this all of the time, regardless of their experience level, because it's just something that's really easy to forget or misinterpret or otherwise just plain mess up. So, because these things are lazy, if you don't put this into a list or an array or otherwise materialize it and store it into something, every time you go to access this to iterate over it or call something like toArray or toList on it, every time you do that, you pay whatever penalty your LINQ method is going to incur. So what I'm doing in this example is every time we go to do an iteration of this select, which is just like the other one we saw, I'm still printing it out to the console, I'm going to wait a full second here. And if we look a little bit below, what I want to illustrate is that I have two for each loops, and each one is going to go over this IEnumerable that's resulting from .select. Because remember, I'm not calling toList here or toArray. So when I go to do this, each time here and here, we're going to go materialize this fully, wait 5 seconds each time, and we'll see it print out to the console. So let's go run it and see. As you can see, it's printing out to the console here, and finally, there we go, all done. And that took 5 seconds times 2. It took that long to go run them all. Now, what will be different is if I call toArray on it just once. So instead of just doing this part, I'm going to say .toArray here. What this will do is force this to be an array assigned into here, and that way we pay the penalty just one time. You'll see that the order is going to be different because when we call toArray, it's going to force this enumeration to happen. So we'll see all of this stuff print before this part and this part. But these two for each loops are now going to go basically instantaneously because we're paying the full performance penalty up here by calling toArray. Let's check it out. And I'm just going to add a console read line above this so that I can press enter and time this properly for us. All right, I'm going to press enter and we'll see that we have this part in the select go first, followed by these other two parts basically instantly. Right, so this is a very different performance profile than what we saw before. So the difference here is that we pay the performance penalty one time, but that does mean that we need to store this entire collection, which it's only 5 numbers. We do have to have a whole copy of that stored into an array. So you do need to be careful that if you're dealing with tons and tons of elements, if you had lists of hundreds of thousands or millions of records, you're going to be making an entire copy of that. So you do need to consider your memory footprint versus the performance penalty of being able to go iterate or materialize these things. And the last example that we're going to look at here is just making our own LINQ method. So what you need to be able to do to have your own LINQ method is we need to have an extension method that operates on IEnumerables. And to do that, we end up having a static class. So I have a public static class just called myLINQ. This name doesn't really matter. It just has to be unique because we're not going to call this part that says myLINQ anywhere. If you look here, I'm calling my LINQ method, but because it's an extension method, we never have to write this out fully. Now, the next part to get your extension method working is that you need to have a static, right? And then you also need to use this. And the way that this is going to work is that we have the name of the LINQ method or the extension method we want to create, and it's going to operate on an IEnumerable of type T. And generally with LINQ, we use generics because we don't really care what's inside of the collection, but there's nothing that says that you can't go, write your own LINQ method that only works on IEnumerables of integers or IEnumerables of strings. You can totally do that, but I'm just writing a very generic one. And to explain it a little bit further, this is going to be an extension method that takes in a type of T, and it's going to return an IEnumerable of type T as well. So the input type of the IEnumerable is going to be the same type as the output for the IEnumerable. And the other part that's interesting here, and you don't have to use a func like this, which is going to be basically a delegate or a method that we can pass in. That's how we get this kind of syntax here. But this is going to be the input type. So again, I'm passing in an IEnumerable of type T. That means that the func that I want to work with here is going to take an input of type T, and this second T is the output of the function I'm going to run. Again, you don't have to do this. You could go write a for each loop or something inside here that, only returns strings, for example, and you don't have to pass in your own selector or function like this, but this is just illustrating that you can be a little bit more generic with what you're doing. But the real big takeaway here is that you want to have yield return combined with your IEnumerable. And that's going to mean that you are making what's called an iterator. So these pieces are what give you that lazy behavior. And that's the whole idea behind the LINQ stuff, is that when you have an iterator, you don't force the evaluation until we have something like toArray, toList, or calling a for each loop. So what Nick's fancy LINQ method does is really just iterates over each one of these things. It's going to write to the console, and then it's going to call this selector. So whatever function we pass in here, and in this case, I just made it multiply the number by 2, that's going to run this and return the numbers. So what this technically does up here is it's going to take the numbers 1 to 5. It's going to say for each of the numbers from 1 to 5, multiply them by 2, right? And what's going to happen is that the console write line will go for each one of them before it's multiplied. So we'll see to the console 1, 2, 3, 4, 5, but the end result is going to be that we have an array that has 2, 4, 6, 8, and 10. And to prove it, I'll put another console write line in a for each loop after this. So what we should see when we go run this is the applying selector called from 1 to 5, and then we have the numbers, like I said, doubled, printed right after. Let's go check it out. And as we can see, we have the applying selector run first for 1 to 5, and then that for each loop that I wrote after from lines 101 to 104, that's going to print out 2 to 10 because it's all of the numbers above doubled. I just wanted to put this back on the screen for you because this is a few different things going on here, and a lot of this syntax can look very confusing if you've never seen it for the first time. So just to reiterate a lot of the different pieces here, if you want to have your own LINQ method, you need to make what's called an extension method. That requires a static class. It requires a static method on that static class. What you're going to need to do is have an IEnumerable, and it does not have to be of type T. You can force it to be a particular type, but you need an IEnumerable. You will need this because this keyword is what makes it an extension method, and that allows us to extend, like we see, some array, some IEnumerable that we can add this method onto. And then the other part, like this here with this func, you don't need that, but you do need to have something that is for each with a yield return combined with an IEnumerable, because those pieces are what give you an iterator and allow you to yield back one at a time the different elements that you want to return. And that is LINQ in a nutshell. So we got to see mapping, reducing, and filtering with LINQ. We got to see how we would do that without LINQ, followed by with LINQ, and we can see that it simplifies the code, at least in terms of number of lines. I also went over some gotchas with that, because if you're not careful about how you use LINQ and IEnumerables, you can run into some interesting challenges. And the last part we looked at was making your own LINQ methods, and I highly recommend you go back, pause the video, have a look at the different syntax and the structure of the extension method that we had to create, because it is a little bit complicated. And if you want more information on that, just search making extension methods in CSharp and compare that to what I put on the screen, because you'll start to notice the pattern for how you can make an extension method for anything and what you would need to do for an IEnumerable to get something that feels like LINQ. If you found this useful and want to see more about iterators, you can check out this video next. Thanks, and we'll see you next time.